Okay, I want to give you a little bit of context here on the overhead in just a moment. So, as some of you are writing this down, I think I had turn in here, but I didn't want that, so that's why there's such a big gap in there. But in case you can't read it, it says how much force is involved when a wagon rounds a corner moving at 7.15 meters per second. And the time of the turn is 1.18 seconds later. The wagon is moving at 14.15 meters per second. The mass of the wagon is 745 kilograms. If 4,200 newtons is reached, it's going to flip over. Okay? So here again, you're just making this comparison. And when we're talking about a wagon, it's a horse-drawn wagon. Okay? So, and I'll give you that little bit of context here in just a moment. So, when it comes to football, does anyone maybe follow college football more than professional, or maybe not at all? Okay? So, when you look at the University of Oklahoma, what is their, you could say moniker, not mascot, but what is their name? Those are Sooners. Does anyone know, I don't know if it's a slang term, but do you know what a Sooner is? It's more like a homesteader, I think. Perhaps back in, I don't know, sometime in the 19th century, it was okay. Start moving west and start settling. Maybe in the 1850s. Maybe I think it has to deal with the Kansas-Nebraska Act. Okay, something to that extent. So we'll come back to this, but again, I want to give you just a little bit of context here, and we'll go ahead and get rolling after this. So hopefully we can actually see that this question is rooted in real science, and this will make sense here, hopefully, in just a moment.
I already got it right.
Okay, away we go here.
Oh my goodness.
Well, watch her ability to roll. When she hits the ground, nice roll. That's what they teach you in jiu-jitsu, Joe. You gotta roll. Jeez. Use your shoulders. Hopefully nobody was hurt, including the horses. It was a nasty spill. Young ladies falling off the wagon.
All right. So one of the things that we see here, okay, we say is the property of inertia. What happens if you take a turn or a curve too fast? You can possibly flip over what it is that you are driving, pulling, whichever. Okay? So, as we look at what we see happening here, some of these forces involved, okay? You've read the problem, okay? I think we're probably up to either 9 or 10 now. What's the next thing you should do? Okay? So, again, I don't mean to keep asking. Okay, so what do we know in this problem? Someone say mass? Okay. The mass is what? Okay. What else do we know? Okay. And that's where we have to differentiate which one's which. So you are correct. There are two velocities. Okay. Now, You are correct when you say that. And how would you know that? Well, maybe. Because it says you have this speed here, and then at the time of the turn, I don't know how long that was that wagon made that curve or turn. I just figured, well, we'll just say 1.18. I really don't know. Then it says later the wagon was moving at 14.15, which means that if this says later, there must have been a speed before this one. So that's how you can actually use that terminology to say, okay, this is our initial velocity, 7.15, because 1.18 seconds later, it was moving at 14.15 meters per second. So then there are two more numbers we have to contend with, and that would be what? Time is 1. What is our time? Okay? And then it's not that we have another number to deal with, but you got to I would say be careful how it is that you actually use this. Your comparison number. We don't always do comparisons, but I hope we can appreciate that some of these problems are based off of real life events. Okay, so this is what will happen if what we see happening, this mass moving at this speed to begin with, accelerates to this speed over that time frame, and see how much force is involved. Because how many variables are in your force formula?
3.
There's 3. So that means you have to know how many of them?
2.
You have to know 2 of them. So we've got our mass, but we don't have our acceleration. You have to solve for your acceleration. Okay? So in this case, okay, what is on the left-hand side of that equal sign? A, because we need to find your acceleration. What is on the right-hand side, on top of the fraction?
14.15.
14.15. And then what do we have on the bottom?
1.18.
Okay? So do we need to cross multiply or anything to that extent? So what's the first thing that you would do?
14.15 minus 7.9.
And that's correct. How would you know that though? Because it's in parentheses. Okay? So then our acceleration, 7?
Yeah.
Okay? Our acceleration is 7 meters per second squared. That's one thing we need to deal with. Can we find our force now? And that is yes. How do we solve for force now?
Yeah, the acceleration isn't 7. You still have to divide it by 1.
Oh, okay. I thought that when you said that it was 7, that was the answer. 5 point what? Now, some people, I got 5.9, I got 5.98. Some people maybe got 5.93. So that's the number that we're going with. Now, how do you solve for force? Just tell me. Okay? So we've got 745, and we multiply that by what we just calculated, 5.93. And our force is what? 4417.85. 4471. Well, okay,
4417.85.
okay, whichever. Okay? Because once we reach this, once we get past this 4, what can we presume from this now? Because what was important here?
That was bigger than
It was bigger than 4,200. So since this force that was generated by taking this turn was greater than 4,200 newtons, that's why you see that wagon flip over. So one of the things, and the commentators are right, you hope that here you have someone sitting up, well, 2 people up off the ground, probably 6.5, 7 feet, and you're making that turn. It's not so much that you're falling from a what you think is a short height, but how you actually might land. Okay? So, luckily the individuals involved that were able to get up and walk off the field. Okay. So that would be our answer, and then we compare that to 4,200 and say, yep, that wagon flipped over, just like what we saw. So next week, we'll probably have some of our first problem solving assignments handed out. And for some people, just breeze right through them. Others, maybe not so much, but it's just the best way that I think for us to not hand the material, but teach you the material for this class. Okay, so I think we'll maybe assign that on. We'll probably assign that on Monday. And you're probably more familiar with the schedule than I am. It's your first year competing in the Homecoming Olympics. I think Wednesday, 4th hour, we don't have class. Then Thursday, it's 7th hour that doesn't have class. So each one gets the opportunity to partake during their science time. Okay. So we'll assign that on Monday. I'm going to go ahead and pencil that in or write that down now. Okay, so then on Monday, we'll say vocab due on
Friday. Right now.
Okay, this is what we'll do. Whichever class, the morning session, it will be due on Thursday, and then the afternoon session will be due on Wednesday. Okay? So, let's see here.
How does speed run your mom's bank account? So red. Day 1, snap all of my pencils. Day 2. Day 2. I'm muy bien happy about it.
Okay. So, we'll fill in the gaps a little bit later. All right. That's all I have. We will catch up to you next time.